In this final core learning objective of Unit 9, we're going to kind of combine our last three units. So we're going to have exponentials, inverses, and logarithms all in the same thing. We're going to talk about solving equations. All right, so we saw in previous learning objectives in previous units, we can solve these types of equations. If 2 to the x equals 2 to the 4, we know that x equals 4. If log base 2 of x equals log base 2 of 5, we know x equals 5. But what happens if these bases aren't the same? What if we had like 2 to the x equals 3 to the 4th? All right, how do we go about solving that? And the answer is, now that we have exponentials and logarithms that we know are inverses of each other, we can use those to help us solve these types of equations. All right, that's actually what I just said. All right, we can use logarithms to help us solve an exponential equation. We can use exponentials to help us solve a logarithm equation. All right, so let's say I had this simple looking equation, log base 2 of x equals 4. All right, I want to get this x by itself. All right, so I can say x equals whatever. But how can I do that? Right now, x is inside of a logarithm. What we can do, if we go all the way back to the very first learning objective of this unit, we can rewrite this as 2 is our base. We raise it to the 4th. All right, that's over here. And we get x. So we can always rewrite a logarithm equation as an exponential equation because they're inverses. And that's going to flip the x from being in a place where it's bad to a really helpful place. And our answer is just 16. And so by using that exponential property, we can get the x out of the bad place. Here, again, x is in a bad place in the sense I can't really solve for an x when it's in an exponent. But what I can do is I can use the inverse. I can rewrite this as a logarithm, log base 3. The number over here is going to go into parentheses, and that's going to be equal to x. All right, log base 3 of 7 is not some number, nice number you could put in a calculator, but at least we know that x is now equal to log base 3 of 7. All right, so we're going to use this rewriting property to help us solve these problems. All right, so here we have these two logs equal to a number. So we can't use the things that we learned in our previous learning objective because there's not a log on the right-hand side. We also had to do a little bit of work before what we did on the last side. But again, we've used our log properties a bit. If we have a plus sign between logs, I can smush them together and multiply the insides. And now this problem looks similar to the one on the last side. I have this log. The x I'm trying to get is inside the log. So I can rewrite this as 3 is my base. I raise it to the 3rd, and I get 4x. Right, now, 3 cubed is 27. I can just do that. And now to get x all by itself, I have to divide by 4. So x is going to be 27 over 4. Right, I started with a log equation, so technically I have to check for extraneous roots, but 27 over 4 is going to work, so that is my answer. All right, so you get down to a point where you have a simple log equation, and then if the x you're trying to solve for is inside the log, you just rewrite it as an exponential, and then the x is in a much more accessible place. All right, so here's another one. Again, we can't do anything yet because there's multiple logs over here, but I can use my rule that says if I have subtraction, I can smush these two logs together, take the first log and divide it by the second log. And now that I have a log equation, a single log equation, I can use my exponentials. 4 squared equals x over 3. 4 squared you can just do. 4 squared is 16. And now to get x by itself, I just have to get rid of that 3. I'm multiplying both sides by 3. And I get x all by itself, and 16 times 3 is 48. Again, because I start with a log equation, make sure it works, but 48 works in the log, so that's good. So my answer here is 48. All right, here's one for you to try on your own, really similar to 2 examples ago, but solve this equation for x. And the answer you should get at the end is that x equals 2. Again, the first thing you have to do is see that there's a plus sign between the logs, so you combine them and multiply. Now you have a single log equation, so you take your base, you raise it to that number, and you get the inside. 2 to the 4th is 16, divided by 8, you get your final answer of 2. All right, so far we've dealt a lot with the log equations, but here we have an exponential equation. And here we can't just do our little trick of setting the exponents equal because there's two different bases, 3 and 5. Sometimes the bases are related and you can do some tricks, but 3 and 5 aren't related at all, so we have to figure out some other way to do it. And there's actually going to be two ways you could do it. All right, so the first way you can do it is just use our log property. Let's just pick one of these as your main exponential. It doesn't matter. I'm going to pick the left-hand side because we read left to right. If 3 raised to the x equals 5x, then I can write that as log base 3 of the thing it's equal to equals the exponent. All right, so if you imagine this was just like a c, then c would go in the parentheses. All right, but c is a more complicated exponential. And then what I can do is we have a rule for rule for logarithms. As if there's an exponent on the inside, I can bring it to the front. And now I have to figure out how to solve this equation. All right, to solve this equation, what I'm going to do is I'm going to subtract this x to the other side. I'll explain why I'm doing that in a second. And the reason I did this is because there's two different things with an x in it. I have to get them to the same side, so when they're on the same side, I can factor them out. And that way that x is all by itself now after I divide by this expression. And I finally get x equals 0. The nice thing with solving an exponential equation is that it doesn't matter what answer I get, because you can plug anything into an exponential. So if I get an answer, that has to be the answer, and x equals 0 is the final answer. All right, so this is option 1, picking kind of one of your logs as your main, your exponentials as your main exponential, and rewriting it as a logarithm. The other way to do it is if I have 3 to the x equals 5 to the x, I can pick any log I want, any log in existence. Let's pick 2. I could take the log base 2 of both sides. And what does this do? If I take the log of both sides, it allows me to bring this x out to the front. All right, so now I'm going to get x times log base 2 of 3 equals x log base 2 of 5. And now I have to do the same thing I did in the previous example. I have to move the x's to the same side. Oops. So that I can then factor it out. And then divide to get 0. All right, so there's two different ways you can do it. You either kind of pick one of your logs as being the special log, or you kind of just use whatever log you want on both sides. Here you could use 2, you could use 8 on both of these, you could use 100 on both of these. It doesn't matter what number you pick because it'll just stay there the whole time. All right, so here's one for you to solve on your own. 2 to the x equals 7 to the x. All right, solve it however you want, all right, and figure out what x has to be. All right, no matter how you do this problem, you should end up with a final answer of x equals 0. All right, what I did, I chose to pick the right-hand side as my kind of main exponential. So I'm going to pick log base 7. All right, the thing that was equal to is going to go inside the logarithm, and it's equal to the exponent. All right, then I bring my exponent out in front. I get the two x terms on the same side, so then I can factor it out. And when I divide, I get x equals 0. That's just how you can solve exponential equations using logarithms. All right, so for this learning objective, you're going to do a skill check. The skill check is going to have 4 questions. All right, it's going to have 2 logarithm questions and 2 exponential questions. All right, so you just solve these equations using the techniques we talked about in this video. All right, and that'll be your skill check for this learning objective.